I pulled up planet formation on the Google search engine. I typed in planet formation with the quotes. You know, it's get it honed in on just that phrase. And then I pulled up a Hubble site. It says, for centuries, astronomers and philosophers wondered how our solar system and its planets came to be. As telescopes advanced and space probes were sent out to explore, we learned more, obviously. And then it says, current understanding. According to our current understanding, a star and its planets form out of a collapsing cloud of dust and gas within a larger cloud called a nebula. As gravity pulls material in the collapsing cloud together, the center of the cloud gets more and more compressed and in turn gets hotter. The dense hot core becomes the kernel of a new star. Did you get where they messed up? It says, as gravity pulls material in the collapsing cloud closer together. Gravity pulls material? A gravitational object causes gravitation, which pulls material. So in other words, they have gravity working absent a gravitating body. Oops. In another site, it says the Planetary Society. Planet formation and the origin of life. On Monday, February 2nd, 2015. This is pretty recent. Blah, 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 blah. We will present a planet formation and the origin of life. He's going to discuss how life evolved in the universe. That looks actually kind of interesting. I don't know why I clicked on that one. But this is the funny one I wanted to see. PFI, a planet formation imager. Now, if you want to find these articles, they'll be the first ones you pull up on Google if you type in planet formation inside of quotes. Planet formation imager. What is planet formation imager? Among the most fascinating, hotly debated areas in contemporary astrophysics, debated, not really. They don't want debate. They try to cover that up. If they are debating about it, they're not talking about it to the public. Are the means by which planetary systems are assembled from large rotating disks of gas and dust which attend a stellar birth. That's the big problem. And that's what I want to discuss really quickly with you guys. The big difference between the Nebular hypothesis and stellar metamorphosis, the theory I'm working on, is the Nebular hypothesis has planets forming around a disk, and the star is a central object. So in other words, the planets around the disk are formed at the exact same time, or the same time, not exact, this redundant, as the central object. In other words, planets are a byproduct of star formation. They're a byproduct. The star is the number one object that forms, and the planets are the leftover remains. Those are just leftover remains. They're just bleh. Now, stellar metamorphosis has it that the star is born as an individual construct. There are no leftover remains in a star formation. If there are leftover remains, it's just going to be interstellar gas. It's never going to do it. It's just floating in outer space. That's what the nebular clouds are. They're not gonna magically collapse because of gravity, absent a gravitating body. In this theory, the star is formed via large electromagnetic effects, and it's born. It's hot, big, bright, shining. There are no leftover remains. And over time, this star, as it wanders the galaxy, cools, shrinks, and dies. That's it. And as it wanders the galaxy, it takes up orbit around other hotter host stars. That's it. And then it makes binary systems with other stars. It makes tritary systems, 3 stars, quad systems, 4 stars. And if it cools down enough and ceases radiating, and obviously the plasma will move to its gaseous state. It becomes what's called a gas giant, and it'll continue wandering the galaxy, and maybe take up orbit around another hotter, younger star, like Jupiter did, and another species will call it a planet. They'll be like, oh, well, it's a planet. See how that works? There was no need for a disk. They're all stars. Now, I know what you're thinking. What about the really small ones? Like Callisto, Ganymede, the Moon. Those are just remains of impacts. You have two older stars, such as a super Earth or Earth, slamming into each other. Obviously, you're going to get some debris. And depending how large the debris is, will determine if gravitation is strong enough to round it out again, or if it's going to remain an oblong structure like 67P, the comet, where it looks like a rubber ducky. That's it, really. It's very easy to understand star science now. We don't have to invoke random models. We don't have to spend billions of dollars on telescopes to find these exoplanets. All we need to do is look up at the night sky. The young ones are really hot and bright, and astronomers call them planets. No, astronomers call them stars, but really, they're planets. They're new planets. It's that simple. One of the barriers to understanding that is rooted in our assumptions. Astronomers assume that stars have leftover remains. They don't have leftover remains after they're born. The star, all the material that the star wanted to form out of is the star itself. It's like saying, as a tree grows, its leftover remains becomes grass. But no, the tree is growing on its own. It's a single individual structure. There is no leftover. Nature doesn't waste things. Nature isn't wasteful. She does everything 100% of the time. It's that simple. I'll bet she does some things a lot more slowly than others. Some things a lot faster. But she's 100%. She leaves nothing to waste. The waste concept is purely a human thing. We think that stars have waste products that become planets. Stars don't waste anything. Alright. Today is March 19th, 2015.